Okay, we're going to look at some problems today from section 3.2 in our textbook involving complex numbers. So the first, we have two complex numbers, right? A complex number is the one that is in the form of a plus bi, where a and b are real numbers. And what we're doing is setting two of them equal to each other with some variables x and y. And what we want to know is for these two numbers to be equal, what would x and y have to be? And so we take the real components and we set those equal to each other. Divide by 9 and we get x equals -4. And then we set the imaginary components equal to each other. And if we divide both sides by 6i, we get y equals -3. So those are the values if we substitute -3 for y and -4 for x. You will end up with -36 minus 18i on both sides. The next one is to simplify. And notice we have a parentheses here around the 2 minus 3i, and we are subtracting that. And anytime we're subtracting a binomial or trinomial, we need to be careful because that -1 really needs to be distributed. So we have 16 minus 2, and then we have the -1 times the -3i, which becomes plus 3i. And now we add, subtract, whatever it may be, our real components, which is 14, and our imaginary components, 3i minus 1i, leaves us with 2i. And in our next one, it's asking us to multiply, and we have a binomial being squared. And remember, we're not allowed to distribute the exponent over addition. And so really what this is telling us to do is to take 8 plus 3i times 8 plus 3i. And now we'll use our FOIL. So we have 64 plus 8 times 3, 24, so 24i. Here we have another 24i, and then here we have a 9i squared. Combining our like terms, we're left with 64 plus 48i. Now remember, I squared is equivalent to -1, so we're going to do that substitution. So now we have 64 minus 9, which leaves us with 55 plus 48i. And then later on in chapter or section 3.2, we were solving some equations involving complex numbers, as well as, let's get that nice and focused there, looking for some zeros. Okay, so we have a quadratic, x squared plus 9 equals 0. To isolate the x squared, we'll subtract 9. We could not solve by factoring because we have a sum of squares, which does not factor. We should have x squared, equals -9 there. So we're going to take the square root of both sides. Remember, the square root of x squared by definition is the absolute value of x. And if you're not as familiar with the square root of negatives, right, we can always break this up into the square root of -1 times the square root of 9. We know the square root of -1 is I, and the square root of 9 is +3. So this equals 3i. And then solving our absolute value equation, we get x equals plus or minus 3i. Okay, over here, similarly, we're going to isolate the x minus 1 squared. So we'll first subtract the 8, get -6, divide by 2, x minus 1 squared equals -3. Now, to undo the squaring, we'll take the square root of both sides. Again, absolute value of that quantity. And on the right side, we're going to get I root 3. Right? 3 is not a perfect square. And our two equations, x minus 1 equals I root 3, or x minus 1 equals -I root 3. We'll add 1 to both sides. And efficiently, we would write this probably as 1 plus or minus I root 3. Although you could have 1 plus I root 3 and 1 minus I root 3 in two separate equations. Okay, lastly, we're asked to find the roots of a quadratic equation. And if we go back to chapter 2, just to have a little bit of a checks and balance, we know that the vertex for this quadratic will be at negative 3, 8. And I'm not really worried about my scaling here. We have a positive leading coefficient, a positive a, so we know our graph opens up. It'll be a little narrower because of the 2, but we have a general shape. So a couple of things. Remember, zeros are the value that makes the function equal to 0. So we substitute 0 for our g of x, which is the same as substituting 0 for y. And we know that we have no x-intercepts, right? So when you were back in Algebra 1 and even earlier on this year, we talked about finding x-intercepts, substituting 0 for y, which in this case is g of x. Well, we know from our graph and from our understanding of quadratics that we actually don't have any x-intercepts. But we do have zeros. In this case, they will be imaginary zeros. So we will subtract 8 from both sides of the equation, divide everything by 2, and isolate that, or undo the squaring. We're going to take the square root. So here on this left side, we're going to get a positive 2i and an absolute value of x minus 3. And now with our two equations, x plus 3 equals 2i, x plus 3 equals negative 2i, x equals negative 3 plus 2i, x equals negative 3 minus 2i, and we can just write that if we would like as negative 3 plus or minus 2i. So, right, we have two roots, because this is a quadratic equation, so we must have two roots. The number of roots is equal to the degree. In this case, both of them are imaginary, and we can confirm that by the fact that our graph, the vertex is above the x-axis, opens up, so we know there's no x-intercepts. So I hope that helps you, and we'll see you soon.